All right, before we start 10.1, I want to mention what's going on in Chapter 10 in general. So, Chapter 10 in general is looking at different ways to write equations, and in particular, it's going to look at different ways to do calculus. So what I mean by that was just sort of using different forms rather than the usual y equals a function of x type forms. And the first section here is devoted to conic sections because conic sections are an interesting place where in a you can write a conic section in a number of different ways. So we're going to start out with the idea of what a conic section is. So geometrically, a conic section is the intersection of a plane with a cone. And shapes are going to differ by how the plane cuts the cone. Now, when I say cone, I mean the mathematical cone, so having both sides, not looking like an ice cream cone. Let's look at some pictures of that. Right, so what I've done is I've gone to this website here for reference, and it shows me a bunch of different conic sections. So again, I said it's the intersection of a plane and a cone. You can see the cone here in red. Notice that I'm saying a mathematical cone, so both sides are included in that. And then the plane here is in blue. And where the blue cuts the red cone, that's the conic section. And these are the four main ones we're going to look at: parabola, circle, ellipse, and hyperbola. Okay, parabola you see cuts it there. The circle, again, when you cut the cone exactly parallel, circle cuts it here. The yellow is the conic section itself. Now, one thing to add, there are some conic sections that are sort of unique that our book goes through that we're not going to be dealing with. These are what happens when the plane goes through this point right here of the cone. So if you move the circle up to where that plane hits this point, you just get a point as your conic section. Or if you move this ellipse up where it goes through, sometimes if you hit it exactly right, or the parabola you hit exactly right, you can hit this line, this outside edge there, and the outside edge there. So sometimes you can get a line, sometimes you get intersecting lines, sometimes you can get a point, but all those are what happens when it goes through this individual point right here. So we're not going to deal with those types of conic sections too much. These are the four main ones that we're going to deal with. All right. So we see we see as far as an image, a geometrical image, what those conic sections do. However, algebraically, we can always write a conic section as an equation with this form: ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, where a, b, c, d, e, and f are all numbers, real numbers, and then x and y are my variables. So basically, algebraically, we can write this, each conic section, as equivalent to this one. And what we should notice is that our variables x and our variable y both have squared components here. Obviously, we can let a be 0 or c be 0 and not have the squared components, but the main parabolic sections, the main sections other than the parabola are going to have both x and y squared terms. So this is what conic sections are going to look like algebraically. Now, there's going to be three types of questions that we're going to deal with in this chapter. We're going to identify key components of conic sections. So we're going to be given these equations, algebraic equations, and be asked to identify some key components that are geometric parts of the conic equations. Then we're going to say, well, if I give you the key components, can we create equations? So these first two are kind of opposites of each other, or reverses of each other, I should say. One of them, I'm going to give you the equation and you're going to find the key components. The other one, we're going to give the key components and we're going to create an equation. Now, the last type of question will be the identification of conic sections from equations. So I'll give you some equations and I'll say, well, which type of conic section is this? All right. And obviously, we're doing this all algebraically in that sense. So we're going to start out with one of the most basic types of conic sections that we deal with, and that's the circle. All right, some books start with a parabola. I'll start with the circle. So the circle, we all know what a circle looks like. Okay, its equation is going to be x minus h quantity squared plus y minus k quantity squared equals r squared. And this equation is always going to be something we get out when we have a circle, where the center is the hk. Notice that this is h and this k. We're subtracting from x, we're subtracting from y in the actual equation of the circle, and the radius is r. So let's take a look at a graph of that. So here's a graph that I've created of a circle, and notice that it has this form. Let's see if I can make this uh, any bigger. Nope. All right, so you can see this circle, x minus 2 squared plus y minus 0 squared equals 16. So the center of the circle is at the point 2, 0. The radius is 4. Hopefully we all know what the radius is. That's the distance from the center to any outside point. I say any outside point, any point on the circle. And so you see the distance from 2, 0 to 6, 0. Obviously, that's a distance of 4. So that's the idea there. And then obviously, if we change this, we can do x minus 3. That would center our circle at 3. If we did x plus 1, we'd center the circle at the point 1, 0. Obviously, we can change y values too. Y minus 2 there, or y, if you add 3, moves down 3. So you can move this circle around any way we want. We can make the radius, if I make the radius a 1, I could do something like that. If you wanted to make the radius 2, 2 squared is 4, so I'd write it that way. If I wanted to make the radius of 3, I'd go 3 squared, 9. So you guys get the point, hopefully. By the way, x squared plus y squared, this is something we saw before when we were dealing in a previous chapter. We said if we ever want to center the circle at 0, 0, we just do x squared plus y squared equals radius squared. So that's the idea. So diagram is that. Equation is what we have there. So here's the types of questions that we're going to be asking. So here's a standard equation of a circle in what we call rectangular form. That means x's and y's. So let's find the center and radius of this circle. I want you to go ahead and push pause on the video and just find the center, identify the radius. So here we go. So this equation is in like the perfect form as far as equations of circles go. We call that the standard form again, but that means that it's going to be really easy to just read off our center and radius. Since we have the form we want, our center is going to have an x value of -9 and a y value of 4. So a center is going to be at negative 9, 4. And the radius is going to be 11. Sometimes people will say r equals 11 because, again, 11 squared is 121. So that's the idea. Now, a couple little real quick notes on this. I did want to just emphasize that when you actually talk about the center of the circle, the center is actually not in the circle, right? Or excuse me, not a point of the circle. The points of the circle are all these points out here on the outside. The center is actually not on the circle itself. So some people mistakenly right? The center is a point on the circle. It is not. The center is a point inside the circle, but not on the circle itself. And then obviously the radius is the distance from the center to the outside. Diameter is the center from one side to the other through the distance from one side to the other through the center. All right. So that's the idea. Obviously, you can start with messier looking equations and kind of make it look like this if you want to. We'll do some of that when we get to parabolas, but not right now. So the other type of question that we deal with is the question that says, let's find the equation given the properties. So the endpoints of a diameter are the points 8, 3 and 8, 9. And so it asks us to find the equation of the circle, a circle whose endpoints of a diameter are 8, 3 and 8, 9. So I want you to push pause on the video and try to do that one on your own as well. All right, so here we have the endpoints of the diameter are 8, 3 and 8, 9. And we want an equation, something that looks like this. Obviously, I'm using the standard form of the circle. So x minus h squared plus y minus k squared equals r squared. So if the endpoints of the diameter are 8, 3 and 8, 9, that tells me essentially where 2 points on the edge of my circle that go through the center. Now, because it's the, excuse me, it's because it's the diameter, it's going to go through the center. And if you look at this, obviously this is a circle centered at radius, centered at 0, 0, centered at the origin, but it would still work for anything. If you look at the point here on one side of a diameter, go all the way across the circle, look at the point on the other side of the diameter, the point halfway in between there is going to be your center. So that's what I would start with. I would start with finding the center of this circle. And like I said, the center is going to be halfway between these two endpoints. So halfway between 8, 3 and 8, 9. Now, if you want to do this classically, like formulaic wise, anytime you're looking for halfway between something, you add things up and divide by 2. Now, you probably could have figured this out without doing that. On this case, halfway between 8 and 8 is just going to be 8. So add them up, divide by 2, you get 8. Here, 3 and 9, so add up 3 and 9. 3 plus 9, divide by 2. And you see that your center is the point 8, 6. Okay, hopefully you know how to go halfway between numbers, right? Add things up, divide by 2. So that's the idea. So 8, 6 is the center. Now, the radius, well, the radius is the distance between the center and the endpoint here. And you can see this has the same x value, so I can not worry about the x value, but the radius is 3. By the way, if you don't have the same x value, the distance formula you can get with Pythagorean theorem, right? So change in it, square root change in x, x2 minus x1 squared plus y2 minus y1 squared. And that would give you your distance between any 2 points formulaic wise. Now we don't have to do a whole lot there because again, our x values of the center and let's say the point 8,9. So if I'm looking at the distance between 8, 6 and 8, 9, the 8 minus 8 cancels out, and then you just get the square root of a square. So you're just taking 9 minus 6 and getting a 3. So there we go. Radius 3, center is the 0.86, and then we can do that. Now we're not quite done yet because remember what we were looking for is an equation. We were looking for this equation filled out. So now that I have my center and my radius, now I can just write in that equation. And again, x minus 8, y minus 6, my radius is 3, so 3 squared over here on the right, which gives me a 9. So my equation of the circle that I was looking for is x minus 8 squared plus y minus 6 squared equals 9. So that's the two types of problems. One is as I give you an equation and you find some properties. The other type of problem is I give you some properties like the endpoints of the diameter, and then you create the equation. All right. Now in the next video, we'll do that for ellipses and we'll do that for parabolas and all those types of things in the next videos.